Hey, AP Statistics. So continuing with the first part of section 5.2. So let's summarize kind of what we've done so far with our basic probability rules, and we'll do an example of this. So we can summarize the basic probability rules in symbolic form. So for any event, the probability of that event, P of A, and we use those capital letters oftentimes to represent those numbers, is between 0 and 1. And so 0 is impossible, 1 is certain, and then everything in between, close to 1 is close to certain, not quite certain, very, very likely, close to 0 is very unlikely. So if S is the sample space in a probability model, so the probability of S is 1, that all of the events, all of the possible outcomes should add up to 1, and so that's the probability that you get a result in a sample space. So when I roll a die, there's a 1 or a probability of 1 or 100% chance that I'll get a 1, 2, 3, 4, 5, or 6, right? That's the entire sample space. If we are dealing with equally likely outcomes, we can calculate a probability pretty nicely. It's the probability of an event is the number of outcomes in that event over the total number of outcomes in the sample space. So it's the number of favorable outcomes out of the number of possible outcomes. If you're dealing with equally likely outcomes, we'll get beyond that. And then the complement rule is that if we want the probability that something does not happen, the probability the complement of A, then it's 1 minus the probability of A. If I want to know the probability I get a 6, it's 1/6. Sorry, 6 on a die. The complement of that would be 1 minus 1/6 or 5/6, the probability I don't get a 6. So you can do some simple to complex calculations using that. And then finally, the addition rule for mutually exclusive events. If we're dealing with events that can't happen at the same time, there's no A and B. If we're dealing with events where there's no overlap between their outcomes, then we can just add the two together for when it's an or. If I want to know the probability of A or B, I can just add the probability of A plus the probability of B. That's only if those events are mutually exclusive. And we'll get into what if they're not, what if there is potentially overlap. And that's our more general probability rules. In this case, we're going to do example problem. Suppose you tear open the corner of a bag of M&M's milk chocolate candies, pour one candy into your hand, and observe the color. According to Mars, the maker of M&M's, the probability model for the bag from its Cleveland factory is, and sorry, let me get this up here. All right, so hopefully you can see that all right there. We've got the different colors and the probabilities in each of those. So blue is 0.207, and so that's and notice that these are the possible outcomes and then the probability of each of those outcomes. These are not equally likely outcomes in this sample space. But we got each of those probabilities. You can copy those down real quick if you want. So then if we're looking to see whether or not this is actually a valid probability model, what we can do is look through those probabilities we just had and add them all up and verify that they do add up to 1. And so at least it seems like it's a valid probability model that covers the possible outcomes, and they got probabilities that add up to 1. So seems legit so far. And then they ask us to say the probability that you don't get a blue M&M. So the probability of the blue was 0.207. And so if we do 1 minus that, that would give the probability of not getting a blue M&M. What is the probability that you get an orange or a brown M&M? Well, in that case, our two orange and brown probabilities were 0.205 and 0.124. We can just add those together because there's no orange/brown M&Ms, and so we can add those two up. Those are mutually exclusive events, and we can just use that addition rule for that set.